As I remember, last lecture we ended up on a question. Did anybody prepare an answer for this one? Why the gas molecule exert pressure on the wall of the container? The answer
Yes,
is
sir.
okay.
I wrote because the gas particles are moving at high speeds, freely at high speeds, and therefore they are completing more successful collisions with each other and the walls of the balloon, which is creating the pressure.
Okay, you scored 1 out of 3 marks over here because yes, you're right. It is because of the collision. But what is the physics going on? What are the processes in between? Uh, Number one is gas molecules move with high speed when they collide with walls of the container. They experience an impulse. Impulse means change in momentum. Rate of change of momentum is force, and force on unit area is called pressure. This is how gas molecules exert pressure on the walls of container, and in this case, balloon. Now, the air pressure inside the balloon is more than the atmospheric pressure. But balloon is neither expanding nor contracting. Why? The air pressure from the inside is more than the atmospheric pressure from the outside, which is trying to squeeze in. So this is how gas molecules are exerting pressure on the walls of the container. At the same time, air outside is exerting pressure to come in. And pressure of air inside is more than pressure of air outside. Then why the balloon is not expanding further? The atmospheric pressure is trying to go in, the air inside is trying to come out, and air which is trying to come out is at higher pressure than the air that is trying to go in. Why the balloon is not expanding if pressure inside is more than the pressure outside? Answer is the walls of the balloon are elastic and they are trying to squeeze in. They also have some energy stored in them, the strain energy, And because of that strain energy, they are continuously pressing inside. So pressure that air is exerting, plus the balloon walls are trying to squeeze in as well. So together, they are equal to the pressure which is caused by air inside. The balloon walls are also trying to come in because of their elastic nature. They have elastic behavior, so they are trying to come in. So balloon walls plus the air outside is trying to squeeze in. The air inside is trying to expand out. They both are equal. That's why the balloon neither expands nor contracts. Now, pressure of gas depends on, number one, temperature. At high temperature or higher temperature, speed of molecules increases, larger impulse on collision, more collisions, hence more pressure. Second is intermolecular space, which is controlled by the volume. Intermolecular space when we squeeze the gas, molecules of gas come closer, hence number of collisions increase even if speed is same. So we are not changing temperature. We are not increasing the kinetic energy of the molecule. We're just making the molecules come closer. Only by doing that, we will be decreasing volume, making the molecules come closer. They will be colliding with one another with more frequency, and hence the pressure will increase. So pressure is inversely proportional to volume. Okay. So if pressure is inversely proportional to volume, then pressure multiplied by volume equals to constant. This means pressure 1 multiplied by volume 1 equals to pressure 2 multiplied by volume 2. equals to pressure 3 multiplied by volume 3, and so on, equals to any pressure multiplied by corresponding volume should have the same answer. So product of pressure and volume should stay same. And that is true for any two quantities which are inversely proportional. Whenever two quantities are inversely proportional, they have same product. Okay. Now this is no need to remember the name, but this law is called Boyle's law. This is Boyle's law. Now, pressure is directly proportional to thermodynamic temperature or absolute temperature. Absolute temperature means temperature in Kelvin. And remember, temperature in Kelvin equals to temperature in degrees Celsius plus 273. Temperature in Kelvin is temperature in degrees Celsius plus 270. That will be absolute temperature. So pressure is directly proportional to temperature. That means that pressure divided by temperature equals to constant. This means P1 over T1 equals to P2 over P2 equals to P3 over P3 and so on up till any pressure divided by corresponding thermodynamic temperature or absolute temperature. Okay, we have discussed heat capacity, experiments to compare the black surfaces with white surfaces. Okay, let's see if we have missed anything. Okay, okay, temperature in Kelvin equals to temperature in degrees Celsius plus 273. We have just done it. Okay, one thing is left, evaporation. We haven't discussed what evaporation is, what are the factors that affect evaporation. Okay, conduction, convection, radiation. Heating objects at execution plan, heating room. Okay. So almost the topic is done. Some things that are not mentioned, but examiners normally gives them is the heating curve and cooling curve. heating curve. So we have a container. This is a container, and it has some solid material in it. This is solid material. It is positioned on the top of a tripod. Now we are heating it from here. This is a Bunsen burner. There's a thermometer. Okay, do not waste energy and time in making a perfect thermometer. Just making a double line and labeling it as thermometer is enough. So this is a retort stand that is holding it. This is a retort stand. It is very common in labs. Okay, the whole apparatus is on a stand. This is a clamp. This is a thermometer. This is a Bunsen burner. This is crushed wax. Wax is normally solid at room temperature. We are heating it using the thermometer to measure its temperature, and we record the temperature, make a table, and then use that table to make a graph. Just 1 second. Okay, this is temperature in degrees Celsius. Sorry, no. This is time in seconds or minutes. This is temperature in degree Celsius. So this is the kind of graph we should be expecting. Okay. Now, let's say this is O, this point is A seconds, This is B seconds, C, D. So if somebody asks you what is happening in any particular interval, for example, from O to A at A, from A to B at B, from B to C at C, from C to D at D. I need more space. Let me make this whole thing go a little up. I can make the separators a little smaller. Okay. So we will be explaining every part of this graph from C to D and at D beyond D. So what is happening from O to A? It is a solid is heated, gaining temperature. At A, melting point is reached. I hope you can see that we are providing heat energy between A and B, but there is no change in temperature. So what is happening to the heat energy that we are providing to the system right now? That heat energy is being used to convert that solid into liquid. So from A to B, melting is happening, and at A, melting point is just reached. Still solid. It is still solid at here at this point. It is solid, but it has reached the melting point. It has reached the melting point. So in between over here, it is some solid, some liquid. So if somebody asks you what is happening between A to B, the wax is melting. So it is a phenomena of latent heat of fusion. Now, what is happening at B? At B, all wax has melted and is in liquid form. From B to C, a liquid is gaining temperature. Okay. Again, it is a case of heat capacity and specific heat capacity. At C, wax at C is wax has reached its boiling point. It has gone to boiling point. This temperature is the boiling point of the liquid. So the wax has reached its boiling point. From C to D, liquid wax is boiling, converting from liquid to gas. At D, all wax has converted to gas. Gas is gaining temperature. The gas will be expanding or exerting pressure on the wall of the container if it is in a closed container. So this is what is happening to a solid which has been heated like this. What is cooling curve? So if we have a container, just 1 second. So there is a container that contains any material which is in the gaseous form. What is wrong with you? Okay. So this is a thermometer inside a container. This container is inside another container. So there is a gas here. This is thermometer. And this is freezer at very low temperature. So gas will be losing heat energy to the surrounding. So what will be happening is this is temperature in degrees Celsius. Sorry, temperature is on Y. The temperature in degrees Celsius and time in seconds. So the graph will be something like this. So this is condensation point, which is same as boiling point. This is freezing point, which is same as melting point. Melting and freezing, they both happen at the same temperature. The only difference is melting is a process where we provide heat energy to the system, and while freezing is a point where we extract heat energy from the system. So if this is another class O, A, B, C, D. So take a screenshot of this thing. This is your homework. You have to make the same kind of listing. What is happening from O to A, what is happening at A, from A to B, at B, from B to C, at C, from C to D, and then at D, and then beyond D. Okay. Take a screenshot. Done?
Yes, sir.